All right, this is Algebra 2, Lesson 28 on page 128. Don't forget to subscribe, smash the like button, and turn on notifications. You never know, I might post a dog video, and you don't want to miss the dog videos. Okay, complex fractions. What is a complex fraction?
Fractions that are complex.
Yes, and what does that mean? That was circular reasoning, wasn't it? It's something like this. It's a fraction over a fraction. That is what makes it complex. But we are going to have variables. All right, but I want to begin with how do we solve these? It's an expression, so the only thing I can do is multiply by what is effectively the value of 1. Now, normally when you divide fractions, you don't see them that way. You see them this way, right? But what have you been taught? We don't divide by fractions, we
Multiply by the reciprocal.
That's what you do. You multiply by the reciprocal of the denominator over itself. That is really what you are doing when you've done this. You've just been taught to do it. When you multiply by this over itself, remember, here's my middle fraction line. The denominator cancels. And, okay, I want to rewrite the original because I want to show you something. Can I simplify terms that are multiplied? Yes, I can. So what can I simplify in 2/5 times 5/3? I can simplify the 5s and it becomes 2/3. Okay, so this is a pattern. I want you to lock in your brain. When you have a numerator over a denominator that is the same denominator in the denominator, you see the denominators are the same? The answer is always numerator over numerator. Always. If I do x plus 1 over x squared plus 5x minus 6 all over abx plus 10y over x squared plus 5x minus 6, what does that equal?
X plus 1 over abx plus 10y.
Because it's the same denominator in the complex fraction. So it's numerator over numerator. Which makes this lesson so easy. Because for a lot of your problems, you're going to have the same denominator. I've also seen this on the ACT, where you have the same denominator. So you write numerator over numerator. All right, so look at example 1. A over B over x plus y over b. We can know the answer already. The answer is going to be what? A over x plus y. But let's prove it. How do I prove it?
Multiply by the
I multiply by the reciprocal of the denominator over itself. And my denominator fraction cancels. Well, it becomes 1, right? But anything over 1 is just what's in the numerator. I can simplify terms that are multiplied. My b's cancel. cancel so that I end up with a over x plus y. So intuitively, you should be able to look at a problem and anticipate the answer. Same with example 2. Example 2 is a over a plus b all over c over a plus b. Mathematically, I am multiplying by the reciprocal over itself, but the result is going to be a over c. But I get there because it's an expression by multiplying by the value of 1 to cancel the denominator. These terms cancel. It's the exact same binomial. A plus c is always going to be the exact same value as a plus c. So when you have the same binomial, that's the only time you can cancel terms that are added. And you end up with a over c. All right, so these are the easiest types of this problem for this lesson. They're going to become more complex. You're not going to be able to cancel them out. But if you have problems like this, you should easily be able to answer them. Numerator over numerator. The other part of this lesson is we're rationalizing the denominator. So you begin with an irrational number in the denominator. So it's under a radical. And the first example is 3 over 2 square root of 5. The only way we can rationalize any number is by multiplying by whatever that irrational number is. An irrational number times itself always equals a rational number. An irrational number times itself always equals a rational number. So, square root of 5 times square root of 5 is what? 5. Always when we have radicals as your irrationals, we will rationalize it by multiplying by whatever that radical is. But because it's an expression, we have to multiply by what is equal to 1. So in algebra, we always make the denominator a rational number. In calculus, it's the reverse. You make the numerator rational. But in algebra, we make the denominator rational. So we end up with 3 square root of 5 over 2 times 5, which is 10. And I ask myself, is there anything I can simplify? And there is not. Because those terms are multiplied, I could potentially simplify. But look at example 4. It's 2 over 3 square root of 12. The first thing you should do is simplify your radical. And the square root of 12 is what? 2 square root of 3. So that you end up, since the square root of 12 is 2 square root of 3, it's 3 times 2, which is 6 square root of 3. Can you simplify before we rationalize? I would simplify before I rationalize. So the 2 and the 6 can be simplified as 1 and 3. So it's 1 over 3 square root of 3. Now I'm going to rationalize by multiplying by the square root of 3 over the square root of 3. and you end up with the square root of 3 over 3 times 3, which is 9. So your final answer should be in its most simplified form. Now, you won't be able to do this on a test. However, could I put 3 over 2 squared of 5 in my calculator, hit enter, and it give me 3 squared of 5 over 10? Yes, you can. So can you check your homework easily? Yes, you can. But I don't want you working your homework by entering the problem, hitting enter, and getting the answer. Because you've got to understand this concept. How do I get from here to here? You have to know the steps, because you're going to get to a place where we're going to have x's and y's under radicals, and you're not going to be able to put those in your calculator and hit enter and get the answer. All right?